Welcome to the one more lecture on random variables. So here I'm going to discuss about continuous probability distribution. So already we know what is continuous random variable. A random variable which takes uncountable number of values is called continuous random variables. So now we will see what is continuous probability distributions. So first we will see what is probability function with respect to the continuous probability distribution. So here I am treating x as a continuous random variable. So if f of x is positive and integral minus infinity to plus infinity f of x dx is equal to 1, then the function f of x is called probability function. So now we'll see what is continuous probability distribution. So if x is a continuous random variable with the probability density function f of x, then the function capital F of x is equal to p of capital X less than or equal to x is equal to the integral varies from minus infinity to the continuous random variable x with the function f of x dx. So this capital F of x is nothing but cumulative distribution function. So if r is any real number, then p of x is greater than or equal to r can be defined by the integral varies from r to infinity f of x dx. So if p of x is strictly less than r, I can take the condition like this: 1 minus p of x is greater than or equal to r, and we know that what is p of x is greater than or equal to r, so we can define p of x less than r is equal to 1 minus integral r to infinity f of x dx. So now we will see what is mean, variance and standard deviation with respect to the continuous probability distribution or continuous random variable. So the mean is defined by integration minus infinity to plus infinity x into f of x dx is a formula for mean. Similarly, variance is given by integral minus infinity to plus infinity x minus mu whole square f of x dx, or we can define the variance as integral minus infinity to plus infinity x square f of x dx minus mu square. And standard deviation will be same for both discrete as well as continuous. It is nothing but square root of the variance. So now in the next slide we're going to see the problems related to continuous random variable, and also we will see how to find mean, variance and standard deviation also. One example: show that the following functions are probability density function or not. The function is like this: f of x is equal to 2x, where x ranges from 0 to 1 and it is 0 otherwise. So we'll see how to solve this problem now. So given function is 2x with the limit 0 to 1. Since here f of x is greater than 0 at the given limit, so the first condition is satisfied here. So now we have to show that the integral minus infinity to plus infinity f of x dx is equal to 1. Then we can conclude the function is a probability density function. So take the formula: minus infinity to plus infinity f of x dx. I am going to replace the function f of x as 2x here with the limit 0 to 1 into dx. So after integrating the function 2x, we will get it x square by 2. 2 gets cancelled, so only left out term is x square with the limit 0 to 1. So now on applying the limits, we'll get it integration minus infinity to plus infinity f of x dx is equal to 1. So hence we can conclude the function f of x is a probability density function. One more example on continuous random variable. A random variable x has the density function f of x is equal to k divided by 1 plus x square, with the limit x ranges from minus infinity to plus infinity. So from this condition we have to determine k, and also we have to evaluate p of x is greater than or equal to 0 and p of 0 less than x less than 1. So now we will see how to find the value of k. So since here the function is a probability density function, it has to satisfy few conditions here. The first condition is f of x should be positive only if k is positive, and the integral minus infinity to plus infinity f of x dx will be equal to 1 here. So now I'm going to replace the function f of x in the formula. So I'll get integration minus infinity to plus infinity k divided by 1 plus x square dx is equal to 1. On integrating 1 by 1 plus x square, we'll get it tan inverse x. So we got it here 2k into tan inverse x with the limit 0 to infinity is equal to 1. So since tan inverse infinity is pi by 2 and tan inverse is 0, I got the equation like 2k pi by 2 is equal to 1. 2 gets cancelled, so the value of k will be 1 by pi. So now we'll see how to find the value of f of x is greater than 0. Since here f of x is greater than 0, obviously the limit varies from 0 to infinity. Only positive limit I can take here. So 0 to infinity with the function f of x dx. So since the function is k by 1 plus x square and k is 1 by pi, I got the integral like this. Integration 0 to infinity 1 by pi 1 by 1 plus x square dx. So after integration again I got it 1 by 1 plus x square is tan inverse x into the constant 1 by pi with the limit 0 to infinity. On applying the limit I got it 1 by pi, pi by 2 minus 0, pi gets cancelled, the solution will be 1 by 2. Similarly, the next I am going to estimate p of 0 less than x less than 1. It means that the range of x is 0 to 1. So I am going to replace this limit along with the function f of x. Therefore, integration 0 to 1, 1 by pi, 1 by 1 plus x square dx will be 1 by pi tan inverse x with the limit 0 to 1 after integration. On applying the limit, the solution will be 1 by 4. So in the next lecture, I am going to discuss about binomial distribution and problems on it. Thank you.